we have achieved soft landing on the moon.
After successfully completing the Chandrayaan-3 mission, the Indian Space Research Organization has announced that the Aditya L1 mission, the first space-based Indian observatory to study the Sun, will be launched on September 2 at 11:50 am IST from Sriharikota. According to an ISRO release, the spacecraft will be placed in a halo orbit around the Lagrange point 1 of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any eclipses. This will provide a greater advantage of observing the solar activities and its effect on space weather in real time. As the ISRO release says, the spacecraft will be put in orbit around the L1 point, from where it will be able to observe the Sun without obstructions. A Lagrange point, as defined by NASA, is a position in space where the gravitational pull of two large masses precisely equals the centripetal force required for a small object to move with them. These points in space can be used by a spacecraft to reduce fuel consumption needed to remain in position. Basically, this means that at that point, the gravitational attraction and repulsion between two heavenly bodies is such that an object placed between them will effectively stay in the same relative position while moving with them. The Lagrange points are named in honor of Italian-French mathematician Joseph Louis Lagrange, and there are 5 of them: L1, L2, L3, L4, and L5. According to NASA, the L1 point of the Earth-Sun system affords an uninterrupted view of the Sun and is currently home to the Solar and Heliospheric Observatory satellite SOHO. NASA's James Webb Space Telescope is at L2. What is special about this orbit is that it lets the telescope stay in line with the Earth as it moves around the Sun. This allows the satellite's large sun shield to protect the telescope from the light and heat of the Sun and Earth. The spacecraft carries 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun using electromagnetic and particle and magnetic field detectors. Of the 7 payloads, 4 will directly study the Sun, and the remaining 3 will study particles and fields at the Lagrange point L1, thus providing important scientific studies of the propagatory effect of solar dynamics in the interplanetary medium. The suits of Aditya L1 payloads are expected to provide most crucial information to understand the problem of coronal heating, coronal mass ejection, pre-flare and flare activities, and their characteristics, dynamics of space weather, propagation of particle and fields, etc. Every planet, including Earth and the exoplanets beyond the solar system, evolves, and this evolution is governed by its parent star. The solar weather and environment affect the weather of the entire system. Variations in this weather can change the orbits of satellites or shorten their lives, interfere with or damage onboard electronics, and cause power blackouts and other disturbances on Earth. Knowledge of solar events is key to understanding space weather. To learn about and track Earth-directed storms and to predict their impact, continuous solar observations are needed. Every storm that emerges from the Sun and heads towards Earth passes through L1. To learn about the formation of solar system, check out my previous video. The instruments of Aditya L1 are tuned to observe the solar atmosphere, mainly the chromosphere and corona. In situ instruments will observe the local environment at L1. There are total 7 payloads on board, with 4 of them carrying out remote sensing of the Sun and 3 of them carrying in situ observation. According to ISRO, the remote sensing payloads which will study the Sun include Visible Emission Line Coronagraph for imaging and spectroscopy, Solar Ultraviolet Imaging Telescope for photosphere and chromosphere imaging, Solar Low Energy X-ray Spectrometer, which is a soft X-ray spectrometer for Sun as a star observation, and High Energy L1 Orbiting X-ray Spectrometer, which is a hard X-ray spectrometer for Sun as a star observation. So, this is the complete Aditya L1 mission. Just like the successful Chandrayaan-3 mission, I hope that it will also succeed. And if you want more videos like this, then subscribe to my channel. See you in the next one.